I met David a few years ago at a SIGSI conference, I think, in US. And he's sort of, I think of as the go-to person for block-based programming. So I'm absolutely delighted that he's come to talk to us on that topic. So he's the assistant professor in the Department of Teaching and Learning in the College of Education, with a joint appointment in College of Information Studies, both at the University of Maryland. His PhD is in the Learning Sciences from Northwestern University, and he's got a degree in computer science. He's been doing research on block-based and versus text-based programming and block-based programming, and also the teaching of computational thinking in science over the last few years. And we're delighted to welcome you, David, to give your talk today. Thank you very much.
Thank you so much for having me. I've said a few times, one of the silver linings of the pandemic is being able to organize events like these. So I really appreciate having a chance to share some of my work. Yeah, so I'm going to shoot to try and talk for around 40 minutes or so. Normally I prefer these things to be more kind of conversational, chit-chatty, but given the context, I think the plan will be for me just to kind of power through. If there are any really pressing questions or anything like that, feel free to drop them in the chat. I'll do my best to monitor. Other than that, I think we'll just get rolling. Okay, so overall, the focus of my work is on the creation of meaningful, accessible, and equitable computational learning experiences for all learners. So this takes a number of forms. So I have a research project with Diana Franklin at University of Chicago called Scratch Encore. This is a upper elementary Scratch-based computer science curriculum where we're thinking a lot about how to kind of go deeper into computer science content while staying in the Scratch programming environment. And if you're curious, you can just Google Scratch Encore. You'll find our website. There's lots of good stuff there. I have a project called Sphero Math, which is a 4th grade math curriculum that uses the Sphero, which is a spherical robot, as a way to integrate computational thinking alongside mathematics content. I'm working with some colleagues in the iSchool on a project we call Impact Libraries, Improving Assessment of Computational Thinking in Libraries. And so here we're thinking about computational thinking and computing and the role it plays in informal environments, particularly libraries, and how to prepare and equip library staff to kind of help students make the most of these learning opportunities. And then a final project I'm involved in, we call Infact, which is a 3rd through 8th grade computational thinking learning curriculum focused in particular on neurodiverse learners and thinking about different opportunities for ways to engage neurodiverse learners across different computational thinking and computer science contexts. And so the reason I wanted to bring up kind of this variety of projects I'm involved in is because one common thread across all of them is the inclusion of block-based programming. And this is either very central, like in Scratch Encore, or is kind of one of a couple of different ways that students will engage with computer science and computational thinking, like in the Impact Libraries project. So I assume everyone on this call is familiar with block-based programming at some level, but just to kind of make sure we're all on the same page. So this is the Scratch programming environment. And so what it looks like to write a program in Scratch is you take a block and you drag it onto the canvas. And if you click on the block, it'll execute. So we have a program that says move 10 steps. I can now drag a second block and you'll see we get these visual cues for how they fit together. And there's an audible snap. And now when I click on my program, I say move 10 steps and change color. Now we can hop over to a control drawer and this says repeat 10. You get this nice little animation showing how we can wrap those 2 blocks and repeat 10. So now when I click on it, it executes those 2 commands 10 times. And then finally, we'll drop on this cat block that reads, when space key pressed, run the program. And so what's important to note about this 15-second program I wrote is, one, we wrote a full functioning program in 10 seconds. We didn't need to touch the keyboard until we were running it at the very end, hitting spacebar. It contains multiple commands executing in a sequence. It contains iterative logic. It contains user interactivity in terms of hitting the spacebar. And all this happened in under 10 seconds with kind of no real formal instruction happening. And so here, just from this short program, we can see a lot of the affordances of block-based programming and kind of why it feels really enticing and exciting as a way to introduce novices to the world of programming and computer science more broadly. And so Scratch might be the best known block-based programming environments out there, but it's certainly not the only one. In the last 15 years, 20 years since block-based programming has really caught on, we have all sorts of different libraries being introduced, including MIT App Inventor, Scratch, Pencil Code, Snap, Code.org's App Lab, And that last from the bottom right, Blockly is notable because it's not necessarily a language on its own, but instead it's a framework that makes it easy to design your own block-based programming environments and embed them into other environments. And so that kind of opens the door to new opportunities to integrate block-based programming in a variety of contexts. And along with just introducing programming environments, we see block-based programming really catching on in more formal contexts. So for example, these are 3 popular computer science curricula in the United States: Exploring Computer Science, Beauty and Joy of Computing, and the Code.org suite of materials. And importantly, at least for this talk, all 3 of them use block-based programming as one of the central ways learners kind of engage with the subject. And notably, all 3 of them use a different block-based environment. So ECS uses Scratch, Beauty and Joy of Computing uses Snap, and Code.org kind of has its own environment based off the Pencil Code library. And so we see block-based programming, which initially lived largely in informal contexts, like Scratch, are moving into more formal contexts and more formal curricula. And so the question kind of at the heart of my research and the heart of the talk today is looking at block-based programming environments and comparing them alongside text-based languages. And in particular, there's kind of 3 questions I'm interested in pursuing, and we'll explore a little bit during this talk. So the first is looking at a side-by-side comparison. So how does block-based programming compare relative to text-based programming environments? The second is looking at the transition from block-based to text-based. There's kind of an often unstated assumption that block-based environments are intended to be introductory and kind of the on-ramp to kind of more fully featured professional text-based programming languages. So we'll spend a little time talking about whether or not that holds true, and if it does or does not, and why. And then finally, a design set of questions where initially I'm kind of setting this up as block-based versus text-based, but that need not be the case. And so kind of, is there an intersection of these 2 that can kind of productively draw on the strengths of both of these 2 approaches? So I'm going to spend a little time kind of working through the methods of how I try to answer these 3 sets of questions. We'll walk through the findings, and then we'll kind of end up with some discussion of kind of recommendations and what we've learned from this discussion. I'm also keeping tabs on the chat, and I've already been called out because my little Scratch video was not Scratch 3. You are correct. I may have recycled that video from a prior talk. You're correct, but you know, everything I said I think still holds true. Okay, so methods and participants. So how did I go about answering these questions, kind of comparing block-based and text-based environments? So I conducted a classroom-based 3-condition, 2-phase quasi-experimental mixed method studies. That's a lot of qualifiers before the word study, but I'll kind of break that down to walk through exactly how this all fit together, and hopefully it'll make sense about why each of those different ingredients was necessary. So first, the study was classroom-based. So it happened in 3 sections of an introductory programming class in a selective enrollment public high school in an American Midwestern city. The same teacher taught all 3 classes, and she taught them all in the same room. And this is actually a picture of the room that she taught in. The classes were racially diverse in a breakdown that roughly matched the school overall. 75 male students to 15 female students, which is not ideal, but is kind of reflective of what enrollment usually is in that school, and was also out of my control as kind of a research, as someone doing a study in a school where kind of the school gets to decide who's in what classes. Roughly half of the students speak a language other than English in their households, and 58% come from economically disadvantaged households. And so what this looks like is essentially this study took place in the 4th, 6th, and 7th periods of the same programming class at the same school. So those are the context in which the study took place. So the study had 3 conditions. So there was a block-based condition, a hybrid condition, and a text-based condition. And the idea was each class would use a different version of our introductory programming environment. And so 4th period was text-based, 7th period was hybrid, and 8th period was block-based. And I want to take a minute to walk through each of those different environments because they're pretty central to the study and kind of understanding exactly what we're testing here. So this is the block-based environment that I introduced students to. I call these environments pencil.cc. And so here we see kind of a lot of the typical features of a block-based environment. There's a palette on the left. We can drag our commands from the left onto our canvas, modify them, and hit the run button, and we get our little turtle drawing a nice little spiral. So this is our block-based condition. The text-based condition. And so in place of the blocks palette and canvas, we have kind of a conventional text-based editor. And so here we're just typing in RT for right turn 111 and hit the play button. And we can see the exact same program, the exact same output being generated. And notably, character by character, the language is the exact same. And then finally, we have a hybrid environment. And so here we have the blocks palette on the left that you can navigate through. But now when you drag a command from the blocks palette onto the canvas, when you drop it, it turns into text. And so students can choose to write the programs just using the keyboard and text initially, or kind of drag blocks in and drop them and then modify them in text. And again, we get the same program producing the same results. And so those are our three conditions. And again, and very importantly, the execution environment, the turtle graphics are identical. The programming language itself is the same character by character. It's just a matter of whether or not there's a blocks palette and a blocks canvas, or a text-based editor, and kind of like what type of composition is supported. So those are our three conditions. The study took place in two phases. So the first phase is kind of this like quasi-experimental phase where it started on the first day of school, lasted for the first 5 weeks. And over those 5 weeks, each of the classes used a different one of these introductory environments. And all three went through the exact same curriculum. So we're kind of trying to control for, they're all doing the same activities. It's the same teacher, it's the same classroom, the same student body. Again, the only difference is if they're in the block-based environment, text-based, or hybrid. So that was the first 5 weeks of school. And then after week 5, all three of the classes transitioned to Java, and then they used Java for the remainder of the school year. And I followed them for the first 10 weeks of Java. So the study was 15 weeks long, 5 weeks introductory in one of the three conditions, and then the next 10 weeks were learning to program in Java. And essentially, that's kind of when I handed off control to the teacher, and the teacher taught the curriculum that she had taught the previous year and always teaches. Okay, so across these 15 weeks, lots of data was collected. So I did observations kind of at the beginning, around the transition at the end point, interviews with students at the beginning, middle, and end, and then attitudinal and content assessments at the beginning, middle, and end. And then the last piece of all this is I was able to, because I kind of designed the three introductory environments and kind of could get access to the Java programming environment students were using, was able to instrument those different environments so I could keep track of, so I could record on a remote database all of the programs student wrote and all of the errors and things like that that they encountered. So I kind of had this log of what students were doing while they were learning across those 15 weeks. Okay, so one last piece in terms of filling in the how do we go about answering these questions that we're interested in, which is particularly around how can we assess students' content understanding, given that some of them are learning in block-based, some are in text-based, and we kind of want to learn the relationship between those two. So what I came up with is what I call the commutative assessment. So I'll give people a chance to, this is a sample question from the assessment. So if you want to take a minute to try and answer this question, and if you are brave enough, you can type in what your answer would be in the chat, and we'll see how folks do. Or you can just kind of think of an answer in your head. If you want to be bashful, that's totally fine. All right, I'm not seeing any answers in chat, so I'm going to assume everyone's being bashful, totally fine. Okay, regardless. So here's one question on the commutative assessment. And so here's another question from the commutative assessment. And so hopefully what's become clear is the idea behind the commutative assessment is that every question includes some small piece of code for students to either evaluate or explain what's happening or describe the output. And every question can be asked in either the block-based or the text-based form. And the idea is over the different administrations of the assessment and within the administrations, within the assessment, every student's answering questions about different concepts in both block-based and text-based ways. And that way we can kind of see how well they perform on, say, questions about variables asked in a block-based form or text-based form, kind of at the beginning of the school year after learning in 5 weeks using either block-based or text-based or hybrid, and then again at the end after learning in Java. And then the second piece of this commutative assessment that's noteworthy is if we look at both the correct answer, which for the record is C, either the correct answer and the distractor questions, is I went through the literature to identify existing documented misconceptions around the topic being asked about, and made sure to include those as distractors. So for example, if a student thinks that a variable is going to kind of remember all prior values, like the variable x was set to 10 and then it was updated to 15, so x is going to be equal to 10 and 15, then there's a distractor like option E would be for a student who kind of holds this incorrect assumption of how variables work. Like that's a totally reasonable way that variables could work. Turns out that they just don't work that way, at least not in these environments. And so the idea there is we trying to get at whether or not different ways of programming kind of promote different types of misconceptions. And again, this is just us trying to understand characteristics of learning with these different environments. Okay, so across those different, in the commutative assessment, all those different kind of data streams, what we ended up with was 74 sets of pre, mid, and post content surveys, complete sets. So 74 students where we had took the assessment at all 3 time points, and 81 sets of complete pre, mid, and post attitudinal surveys. A total of 35 interviews, 40 observations, and then the teacher also had students keep journals. So we have these interesting journals where students are doing things like writing out algorithms and kind of describing what their programs are doing and things like that. And then the last piece is that because we're recording programs that students are writing, we have 147,000 pencil.cc events. So that would be something like adding a block or running a program. And we have all those programs, 11,000 Java programs and 6,000 Java errors. So this is kind of the full set of data that we have kind of collected over this 15-week study. Before diving into the findings and to build suspense, I'm going to give just 30 seconds if anyone has a clarifying question. Richard, I see your question, but I don't know if that's clarifying so much as discussion. So maybe if you're okay with that, we can leave that to the end. But just want to make sure we're all on the same page in terms of kind of what. Excellent, thanks, Richard. Okay, and again, lots of time to discuss at the end of this. All right, so what did we learn? So first was a kind of a confirmation of this intuition that block-based programming is easier than text-based programming. And so looking at how students talked about block-based versus text-based, we find kind of unsurprisingly, but kind of a nice validation that students overwhelmingly perceived block-based programming to be easier than text-based programming. And we can see that in student quotes saying things like learning Java is more complicated than pencil.cc, or in Java, there are no blocks to help out. So it's basically done from scratch. I assume no pun intended. But anyways, like this is kind of what we'd expect. And so students are saying the types of things that we expect that block-based programming would be easier. So the next bit is trying to figure out why do students think block-based programming is easier? And so I analyzed both from written responses as well as interviews the different ways, different affordances of block-based programming that students identified. So for example, students would talk about how blocks are easier to read, saying things like Java is not English, it's in Java language, the blocks are in English, it's easier to understand. This is kind of attending to the natural languageness of blocks as being, helping students, making them either easier or just perceived to be easier. I'm talking about the shape and visual layout, and that's kind of like puzzle pieces and kind of the kind of this central blocks-based visual layout. They talked about blocks being easier to compose, and to me, this is just the thought that dragging and dropping blocks is easier than typing things in character by character, especially for younger learners who might not be as fluid with the keyboard. They also talked about this idea of browseability that I find really interesting and powerful, saying things like the blocks kind of jog your memory. And the idea here, yeah, exactly. Yeah, thank you, Richard. The idea is that recognition is much easier than recall. So they don't need to know beforehand everything that's possible. Instead, they can just use the environment itself to inform them about what's possible. He also said some interesting things about how blocks make it easier to support for trial and error, kind of the tinkerability of blocks. This notion of prefabricated commands that you can kind of have blocks that do more at one time. And then visual outcomes, which is less about the block-based interface, but more about the environment which it's situated. So so these are things that students identified as affordances. We also found some perceived drawbacks of block-based programming as reported by our participants. So for example, students said that blocks are limiting, there's not a block for everything. Slower authoring, it seems like when there's more blocks, it's more confusing. And then this last one came up a few times, but is potentially pretty problematic, this idea of inauthenticity. If we actually wanted to program something, we wouldn't have blocks. Which certainly came up, especially among students that were kind of more eager to get onto Java and this overarching sense that block-based programming is kind of like kiddie pretend play programming. And I feel like for people who've taught this especially like in high school or beyond, you've certainly heard this type of feedback. So that's how these are it's important to say these are all students' perceptions of block-based. So this is how they talked about and perceived block-based programming. And interestingly, in the study, as I showed before, saying things like blocks are limiting, there's not a block for everything, the programming language itself was identical character to character. So like the language, there's no difference between language. It was just the perception of what the block-based and text-based modality, the interface over it, how that was perceived. Okay, so how did they do on the assessments? So this was our pre-assessment. So this is how students performed on the commutative assessment at the start of the study. This is nice. We run our statistics. We see that there's no difference between the three conditions. Okay, so now we're going to try a second attempt at some audience participation. So this mid-assessment happened after students spent 5 weeks learning in either block-based, text-based, or a hybrid environment. So if you be so bold, if you want to take a guess as to which condition you think students scored the best in, if you want to type it into the chat, either blocks, meaning you think students in the blocks did the best, hybrid, students in the hybrid did the best, text, students in text, or you can say no difference, that they all did the same. Okay, here we go. So we sent blocks, hybrid. Okay, this is exciting. No votes. Interesting, blocks. So no votes for text yet. I don't know what that says about us as a community. Okay, so it seems like blocks and hybrid are taken away, and no one said that there'd be no difference. Okay, virtual drum roll. Ta-da! Okay, so first, importantly, all three conditions did better. So students learn statistically significantly better in all three conditions. So this is good. Everyone is learning. But importantly, we see a statistically significant difference in performance between the block-based and text-based condition. And so to sum this up in one pithy graphic, after 5 weeks, students in the block-based condition scored higher on a content assessment than students in the text-based condition. There's a lot to unpack here, but kind of at the highest level, this is what we learned, that students after 5 weeks did better after learning in blocks than in learning in text. I want to take a quick sidebar, and so we'll return to, so the follow-up to this is like, okay, what happened after they moved into Java? And we'll get to that, but I want to take a quick detour into what I think is this really interesting kind of study that, well, I'll just dive into it. Okay, so in the United States, we have this AP mechanism. It's called Advanced Placement Courses. It's the closest thing that the United States has to a national curriculum. And the idea is it's a set of classes that students can take in high school that will count for college credit. And because it counts for college credit nationally, it's a nationally administered program. And so I think it's 4 years ago now, they introduced a new advanced placement course called Computer Science Principles. And the idea is to introduce computer science as being more than just programming. And so it includes things like data and design and robotics and HCI, as well as programming and algorithms and these other ingredients. But one of the things that's really interesting about the AP Computer Science Principles approach is that it doesn't have a single curriculum. There's no specific, it's not a single curriculum. There's a bunch of different approved curriculums for the course. And so here are 7 images or 7 different curricula that have been approved for this class. And interestingly, these different classes are using different programming environments. So there's some approved classes that are using things like Scratch that are block-based. There are some that are using Python and Java, and there are others like code.org that are using environments that are a blend of block-based and text-based. And so the idea is a school can teach one of these curricula, call it AP Computer Science Principles, and then at the end of the year, the students will take a test to determine whether or not they will receive college credit, i.e. have they mastered the content that's a part of this curriculum. And so the really interesting question that arises is, and for a whole bunch of reasons, the final exam includes a pen and paper written assessment at the end of the year. So the question becomes, how can you design a pen and paper assessment on computer science knowledge where some kids have learned in block-based programming and some kids have learned in text-based programming? And you, the administrator of the test, don't necessarily know what environment or language or modality students learned in. And so that was the challenge before the AP board and the people who run this this AP Computer Science Principles course. So what they ended up doing was inventing their own programming language, which is obviously the answer of what you're supposed to do. And so they designed their own programming language, and it includes these different kind of categories of commands. And so the result of this is on the test, you'd see programs that look kind of like this thing on the right, where the question would be kind of, what does this program do? Or like, what is the value of sum after such and such? But because they don't know whether students learned in a block-based environment like Scratch or a text-based environment like Python, the creators of the exam created a second programming language that's the exact same as the first one, but now it's a block-based version. And so instead, so what that means is every student who takes the test will be answering some of these pseudocode questions in text and some of the pseudocode questions in blocks. So it's not that there's two versions of the exam, it's that there's two versions of questions within the exam. So every student is answering both blocks and text questions. I appreciate the running commentary in the chat, and I have similar thoughts. So okay, so to me, like, right, I just presented, I did this study about kids learning in block-based environments, and these are all the perceived affordances of why block-based environments help kids. And if you look at kind of this list of perceived affordances, or not why they help, but why students think that they help them learn and program. If you look at this list of perceived affordances, really the only one that's there is shape and visual layout. But even that is kind of like a watered down lame version, because it's like just ovals and kind of like rounded edges rectangles. So like there aren't really notches, like there aren't slots that kind of say anything about data type or anything like that. So we're just getting kind of this like not particularly inspired version of a text-based, of a block-based programming environment. And also this is a read-only pen and paper exam. So they're never writing a program in this environment. So there's nothing about composition. There's nothing really about browseability. There's nothing about tinkerability. It's just a static presentation of programs in these two ways. Okay, so right, so essentially I just kind of presented this conclusion that blocks are better than text. So we have this kind of revised question about whether or not block-based questions are better than, this block-based pseudocode is better than text-based pseudocode. And so to answer this question, I essentially took the commutative assessment I presented before and created an AP computer science principles version of the pseudocode and all of the questions. And there's this nice one-to-one mapping between the two. And then I partnered with code.org, who runs a lot of these national, or helps to, runs a lot of, and provides professional development for a lot of these national computer science principles, teachers and courses. And so was able to get my my assessment into their materials, and so managed to get around 5,000 students from around the country to take this 20-question assessment. And so now I'm going to ask the same question I did before, and there's no hybrid in this case. So the question is, do students do better in blocks? Do they, when questions are presented in a blocks-based form, when questions are presented in a text-based form, or is there no difference between the two? And so if people want to be so brave to type their thoughts, they all fail. That is, I don't know if that's an option. So vote for blocks. No difference, text. Okay, we're seeing a little more variability. So my, and keep coming. So my kind of initial professional opinion is I wouldn't have expected for there to be much of a difference between the two, because kind of like as I showed from the perceived affordances, there aren't that many differences there. But this is why we do the research. So what we see here, that the grayscale bars on the far left are average performance in block-based questions and text-based questions. There are 10 questions in each on this 20-question assessment. And we see that students do statistically significantly better on the blocks version of questions than on text-based versions of the questions, which again is not what I would have expected. And so what we see is students perform better on block-based questions relative to text-based questions. But then interestingly, and I think very importantly, if we look at students who are historically underrepresented in computing fields, particularly female students and students from underrepresented minorities in computing as defined by code.org, those students actually saw greater benefit from the shift to blocks from text than their male or non-underrepresented counterparts, which I think is a really interesting and kind of important finding. Suggests that the blocks compared to text is beneficial, and it actually might be benefiting the exact kind of audiences and groups who we most want to support in terms of kind of advancing in computing and kind of investing and getting excited about and pursuing computing, whether professionally or just kind of to pursue their educational careers. Okay, cool. So that was a little sidebar into this AP computer science principles study that emerged. I thought that was pretty interesting and surprising. Okay, so back to the main study. So this is where we left off. We have this big conclusion, maybe big, I think it's big, exciting. Students did better on block-based and text-based. So that was at the midpoint of the assessment. So after 5 weeks, all of the students then shifted to Java. And so then spent 10 weeks learning in Java. And then after those 10 weeks in Java, we re-administered the commutative assessment. And so this is the third and final audience participation part of the talk. How do people think these three conditions did? So who do you think scored the highest on the post-assessment? Blocks, suggesting they learned a bunch in block-based environments, so when they transitioned to text, they were kind of still significantly ahead, so the block students did the best. Text students did the best because they'd been learning in text this whole time, and so they, like, that kind of leapfrog them over the blocks. Or hybrid, who's in the middle, like having the dual modality was enough to kind of put them over the top. So lots of text, some hybrid, text caught up, or there's no difference, like they kind of ended up in the same place. Same. Okay, so virtual drum roll, please. So what we see is no statistical difference between students after 10 weeks of Java. So essentially what the story, kind of like zooming out, what the story looks like is, for the first 5 weeks when using these differential environments, we see students in the block-based environment doing significantly better than text-based. But then after shifting to Java, with hybrid kind of living between them, but then after shifting to Java, kind of a conventional professional text-based programming language, we see those gains made in the first part disappear, and students kind of end up in the same place. And so kind of one pessimistic takeaway is that, you know, it doesn't matter, because in the beginning and end, they just ended up in the same place, so it doesn't really matter what they took. That is, as you can maybe guess, not my takeaway from this. So there's a few things that are worth noting about this finding. One, which I think is the most significant, is the way that the study was designed. The teacher didn't employ any particular pedagogical strategies to kind of help bridge the transition from blocks to text. So you can imagine teaching kids in a block-based environment, and then when you get to text-based environment, like as you're introducing a new concept or keyword, you would bring up the block-based version and say, hey, remember when we were doing this thing? Like, this is what it looks like in this other environment, or here are the parallels, and like curly braces are doing the same thing as kind of the C-shaped nesting you get from blocks, like doing that explicit scaffolding to help students kind of make these conceptual links. None of that was done as part of the study, and part of that was from trying to decouple the environment itself from kind of pedagogy and all these other dimensions. Another part of it is just like the teacher was teaching the same lesson 3 times, and would be difficult for her to kind of teach differently the same material in consecutive lessons based on what students had done before. And also because like, there's just lots of open questions around pedagogy around this piece. So a second thing worth mentioning is, up to this point, I've only talked about conceptual learning gains. And so I haven't dug into any of the attitudinal or affective dimensions that also kind of tell part of the story. And so with that, I'm gonna transition, just talk a little bit more about what we learned on our attitudinal assessments that'll fill in another dimension of this, story. And so again, pre, mid, and post attitudinal surveys, they had around 25 questions. 18 of them were 10-point Likert scale questions that were conceptually grouped. And then we had some other kind of short answer definitional type questions. So I just want to pick out a few of the findings from this. There's a whole lot more that can be said, but for now, just kind of some high level things. And so again, this is on a 10-point scale, and the y-axis here is cut off to kind of zoom in and make it clear what the differences were. So at the beginning, this is looking at aggregate confidence scores, and these confidence scores were taken from a couple different Likert questions, like I will be good at programming and I will do well in this course. So despite those numerical differences, that's not actually statistically significantly different. At the outset, if we look at how they did after 5 weeks in their introductory environment, what we see is a significant gain for students in the block-based condition, but really no change in text or hybrid. And then after 10 weeks in Java, we see a statistically significant drop for the blocks condition, but again, no change in hybrid or text. And then if we look across a bunch of these different dimensions, we see that pattern kind of repeating itself, where students in the blocks condition had a generally positive experience for the first half, or for the first phase, and a generally negative experience or negative trends in the second phase, with text kind of having the opposite. So here's our aggregate enjoyment score, where students, like blocks-based students, saw an increase and then decrease. Looking at programming as fun, we see blocks having an increase then decrease, whereas text kind of being the same and increase. Programming is difficult, and there's an interesting one in that students in the blocks condition thought programming was more difficult after learning block-based programming, despite doing well on the assessments, which there's a bunch to unpack there. And then a third one I think is like particularly interesting and demonstrative of the pattern is in terms of students' interest in taking future computer science courses. Students in the block-based condition their interest increased, whereas text and hybrid decreased. But then after the transition to Java, we see that pattern flip. And this is potentially particularly consequential, thinking about like how classes are potentially sequenced and what opportunities students have to decide to not pursue future computer science and like enroll in a second course versus, or to decide to drop or switch courses. So an interesting dimension there. I'm gonna hop ahead a little bit. So one of the takeaways from this, in terms of general trends I just kind of talked through, there's also a little bit, it just ends up being a bit of a messier story in terms of kind of how the attitudinal and affective dimensions of this story played out. It's not quite as clean as the conceptual, but there's lots of trends here and kind of suggestions of, and just kind of like things to think about and more work to be done. The last bit, because I want to ensure that we have time for discussion and breakout groups and then we get back together. So the $10,000 question is, so what should I use in my classroom? And as you can imagine, I kind of get asked a lot, asked this a lot, and this is kind of the thing that teachers are most interested in. And so my answer to this question is kind of getting back to this idea where I had initially kind of set this up as you either get blocks or you get text, and these two things are mutually exclusive. And then I was like, oh, well, maybe we can kind of come up with some hybrid environment. This was my hybrid where it's like a little bit text, a little bit blocks. That seems really promising. What I actually end up recommending, and I think is the most promising, is this idea of environments that support both block-based and text-based environments. So for example, this is the pencil code environment that I used kind of like as the base of these studies. So this is what it looks like to program in pencil code. So you can write programs in a block-based interface. So here we're dragging blocks. We have the browseability of the blocks palette, but then you can just click a button and it becomes a fully featured text-based editor. And now we're just writing it in a text-based environment. And I make some edits and then I can go back to blocks. So the idea here is it's not blocks or text, but it's blocks and text. And what I really like about this approach is it essentially is giving agency to the learner to decide whether or not they want the various scaffolds and supports that come with block-based programming, and they can both decide if they want them as well as when they want them. And so we did an exploratory study with Nathan Holbert looking at this, and we found, and there's some other work on this, and this is kind of like a whole nother talk, but we found students over the course of the semester started spending more time in the blocks-based interface, but as their confidence and experience grew, by the end of the semester, at the end of the course, they were spending more time in the text-based environment. And we could also see when students decided to move back and forth between block-based and text-based. So for example, we saw students would be working in the text-based interface, and then if they were going to add a command that was new to the program that they hadn't used before, they would go back to the blocks environment, drag that block into their program, and then hop back into text to continue editing it. And so in doing so, that suggests this browseability, both in terms of what's possible, but also what the syntax is for a given command. They're like, oh, I know that there's some sort of like looping construct thing I can do. I don't remember exactly what it's called or exactly how it works. They would go from text back to blocks, introduce it in the program, and go back to text. And in that way, it's a nice kind of demonstration of the affordances of blocks, but also students who want to be working in the text-based environment for kind of whatever reasons, maybe perceived authenticity or just that's where they're more comfortable, being able to still get some of the advantages of blocks. So I think this type of environment is really exciting and promising. And there's been some work, like this work I did with Nathan Holbert, and there's some other work by some Japanese researchers. I think his name is Yoshimi Matsuzawa, did some really nice early work on a Java version of this. When teachers ask, that's generally where I kind of come down the spectrum, if that's an option. Okay. So with that, I think next up is you guys moving into breakout rooms and chatting about all this and then coming back. And I'm really looking forward to the conversation and the questions you have. So yeah, look forward to it.
Thank you very much. Thank you very much, David. We can all do jazz hands or whatever we do to say thank you. Really, really interesting talk. I think we've got lots to think about. Diana will put us into breakout rooms, 15 to 20 minutes. And in there, you've got some work to do. So I want you to come up with some really good questions for David. And you can use your Zoom whiteboard you all know how that works now, your Zoom whiteboard to make notes and then post them into the chat or however. and then we'll have a good discussion when we come back. Great. Well, thank you very much again, David, for the wonderful presentation. I think there are probably lots of questions. Some of them came in the chat, but it's really nice if people can wave their hands at me, or their yellow wavy hand things through the reaction button, and ask David a question in person, or I will pick on you from the chat to ask the question, so it's not just me talking. So anyone like to ask the first question to David, wave your hand at me, or I will select some questions from the chat. Neil, welcome. Neil's got a question for you, David.
Yeah, so thanks for your talk, David. We enjoyed it. So one thing that we talked about briefly in our discussion group was you've got this blocks context, the hybrid context, and the text-based context. And it seemed to us that the text-based was a sort of deliberately low-tech text editor, in that it sort of didn't have, say, for example, autocomplete, which meant that they had to sort of recall all the commands themselves. Whereas the hybrid felt almost a bit more like a souped-up text editor, in that it had this sort of cheat sheet that they could use, but they were still programming in text. So we felt, in a way, that blocks versus hybrid, or maybe I don't know if I can speak for my group, blocks versus hybrid was sort of an interesting comparison between two powerful editors, whereas text was maybe sort of disabling what text is capable of. I don't know if you have any thoughts on that.
Yeah, I mean, you're right that the text editor, yeah, wasn't a fully souped up, didn't have all the bells and whistles. And what we did do, and this didn't end up in the talk, but what we included was this thing we called the quick reference, which is this like essentially like a glossary of all the different commands, and you can click on them and like get a little tutorial of how they worked. And this quick reference was present in all of the environments. And so this was kind of our way around, this was the way that we provided kind of like conventional scaffolds in the text-based environment. So it wasn't just that they had to memorize things, they still had some resources available. But again, like that's not quite the same thing, and it's taking out of the context. And yeah, things like autocomplete or like suggestions for arguments or things like that certainly belong in an introductory environment. Part of that was to control for like the vanilla version of text editor. Part of it was like full disclosure, the fact that like those features didn't exist in the editor in the first place, and like given everything that went on in this dissertation, like wasn't like in a hurry to like implement a whole bunch of new features. The other comment to make, you're describing the hybrid environment as a souped up version of a text environment with like a bunch of really nice features. Like I often, like that's how I think about it, where I think there's a lot of cool potential for introducing block-based features into conventional text-based IDEs. For example, like when you're importing a new library or API, to have like a block-based browser of what's available in that library for you to like kind of get familiar with it before you kind of move on, like before you kind of have internalized it and can just kind of use it more natively. I think is a really cool application of what a hybrid environment looks like. And in that case, it's exactly what you're describing, which is like a feature overlaid on top of a text-based IDE that kind of provides additional scaffolds at particular places. That's a slightly long-winded way of saying really good question. And you're right that in some ways we did hamstring the text environment a little bit in terms of limited functionality, but there's still some things that kind of like we did throw some, provide some supports to the text-based conditions, so they weren't totally left flailing.
Okay. Thank you.
Yeah, thanks.
Thank you. Who else would like to ask a question? There's Hayley, do you want to ask your question?
Hello, sorry, it was my group's question.
Your group's question.
So yeah, well, it was a mixture. So the first one was quite a specific one about the program Snap programming, and whether it's apparently JavaScript and HTML applications, and it was what your feelings were about that, and whether it was a good kind of hybrid type.
So this, so for those who are not familiar, Snap was essentially an attempt to take Scratch and make first order functions, and then kind of like takes block-based programming to like the 11th degree, where it can kind of do everything. And so this slide shows some of the more advanced capabilities of Snap, where you can have arrays and collections and functional programming and object-oriented programming and inheritance and blah, blah. These are pictures I took from the Snap like handbook thing. It's developed by a group out of the University of Berkeley, freely available, runs in the browser. I think some of the stuff that, especially Jens Monig, who's one of the lead developers on it, has like a Twitter feed where he just like every now and then will update. Here's a video of like, look what you can do in Snap, and all these like really incredible things are happening in just 4 blocks. Super cool, super powerful. I mean, I'm a fan of it, but going back to kind of where I ended my talk, I think there's more potential for a handful of reasons for the more like what I call dual modality environments, where you can kind of move back and forth between the two, where you can kind of be in the block-based and then move on into text-based. I kind of like that approach more for some reasons I've already discussed. But that being said, like I think Snap is a wonderful example of kind of like a way to push back against the misconception that blocks are limiting and you can only do so much, because you can actually do some really sophisticated, powerful things.
Thank you. So can I ask another one quickly?
Sure.
You may.
Thank you. I just want to make sure I don't miss anyone's questions out. So it was about the mainly the type of tasks that the students were doing in the lessons, whether they were in your study, the main study you talked about, whether they were very structured or if they were more kind of freely able to do what they wanted. And also about the level of programming experience that the students had in both of the studies, and whether this could have affected why they had the benefit of the blocks versus the non. If you were an underrepresented group, were you more likely to have less experience of programming, and that's why the blocks were benefiting you?
Yeah, great questions. So the first question around the curriculum. So I designed it such that it included a mix. So for every concept that was taught, it included one activity that was kind of like drawing, graphical, visual oriented, that was usually a little more creative. And a second activity that was a little closer to kind of like text manipulation things. So there's a balance, and usually a little more like constrained in what needs to be done. So there's a balance between a little more open-ended, creative, and constrained. And then the final activity, the like summative project, was very open-ended, and kids did all sorts of like really cool, fun, creative things. So there was some attempt to balance those things to get at like, what if text-based is better aligned to constrained specific tasks, and the block-based is better for like creative whatever things. So we did try and control for that. I haven't done an analysis to see if that actually ended up playing out, but in the design we tried to balance that. Can you repeat your second question?
So sorry, and it's about the previous experience of in programming of your participants in both studies.
Yeah, we don't. I don't remember offhand. I mean, we did see a significant difference on the pre-test between the different conditions, and kids were like more or less as random as you can get working in a public high school. We're kind of allotted to these 3 different conditions, so it's not like this. All of the more advanced students were in one condition versus another. So I think we're okay on that front. There's definitely a longer story to be told for that AP Computer Science Principles pseudocode test. One, because there's way more students, but there are some other factors that might be feeding into what's going on there in terms of like, while we don't know what environment that they were using, for the most part, we expect that they were using block-based environments. Also, given those were taken in code.org classrooms, and the professional development that code.org provides is for the most part for first-time teachers who are generally teaching in block-based environments. So like, we don't have the data, but we can kind of assume that for the most part it was students who had less prior experience were more likely to spend more time in the block-based environment. I think I'm trying to think if there's research particularly on that. I guess the short answer is kind of like, that's probably part of the story, although like off the top of my head and in what I presented, I can't answer that question directly, but I think that's like one of the ingredients explaining that would contribute to what we saw, or what we found.
Sorry for sneaking in so many questions.
That's all right. And I think kind of relates to a question I think that Celia put in the chat earlier about the pedagogy that you use with the different block-based or text-based, whether the pedagogy is different. Celia, did you want to reiterate that point? Because I think it's quite important.
That's really what it is. I think if you're teaching, what you have to hand to help you in your task will frame your pedagogy. Obviously, you have a vision, you have your aims and objectives, but I suspect it's having manipulatives or having a block-based language might shape your teaching. You won't define it. It's not it, but I just think that will make a change in how you teach. And I happen to think that how you teach any of this is critical in learning outcomes, as you do, Sue, in your PRIM model. Does that make any sense?
Yes, I suppose the question for David is whether they, whether
I froze for a second.
pedagogy was different. Yeah, it's the same teacher teaching different environments. Were they changing their pedagogy? Yeah,
sorry, I froze, so lost the second half of that question, but I think you're, I mean, I completely agree that pedagogy is essential and pedagogy will be informed by the tools at hand and you can't fully separate those. In the case of the study, it was the same teacher across the 3 classes. And also her teaching style in general was much more like providing some static resources and having it be much more studio based. So a lot of like kids working on their own, and she was more coach than like formal, like let me introduce concepts, blah, blah, blah. Which again, doesn't not to diminish the role of pedagogy, but just like kind of that's how it played out in this study. But I mean, in general, I think the relationship between pedagogy and tool, particularly in learning to program and programming environments, to me is one of kind of these big open questions and things that there's just like a lot more work or research I think that should be done in that space. And there's starting to be more of it, but yeah, really understanding how to make the most of the affordances of these different introductory programming environments, given that many of them were initially designed for contexts where there's no assumption of having a teacher present. And so they're like trying to cram in as many scaffolds and supports into the environment itself. Thinking more about kind of like how the teacher makes the most of those. And maybe are there times to kind of, it's productive to move some of those scaffolds out of the environment into the hands of a teacher, kind of like something like that. But yeah, great question.
Mm. And looking at the other questions that have come up, just going to ask Catherine, you had a question from your group, which is I think the question everyone has about transition.
No.
Hi, yes, we certainly did. So I kind of suggested my group could ask the questions for themselves, but Celia's sort of been in there already as well, so she's doing a great job sort of providing thought-provoking ideas too. Yeah, so we spent a bit of time talking about how to effectively support learners from transitioning from a block-based to a text-based programming sort of environment. And I guess some of that is attitudinal, and some of the results that you shared from the attitudinal domain are sort of relevant here. And I wondered if you'd done, so where you'd got a list of advantages and disadvantages of block-based programming environments, I wondered whether you'd done something similar with learners for them to see the advantages and disadvantages of text-based environments as well.
Yeah, interesting. I haven't. That's a really interesting idea. I haven't, and like my proxy for that had just kind of been looking at drawbacks of block-based as like implicit affordances of text-based, like more authentic, more powerful, I guess faster authoring, given the 3 that were listed. Yeah, I haven't, and that'd be really interesting. One of the kind of like the tricky things, and especially as you move into text-based languages, is the relationship between the language and then the larger kind of environment in which it's situated. Because, and this gets back kind of like Neil's comment about the supports provided in the text-based editor. Like in asking students about whether or not they like Python, you're really asking about, do you like Python in this, in integrated development environment that has all these different bells and whistles? And it's like, oh yeah, I really like Python because I think autocomplete is really useful. It's like, okay, like that might be true, but like that's not necessarily a Python thing as much as it is an environmental thing. So disentangle, I mean, that comes with block-based as well, and certainly like talking about Scratch as like Scratch is great because like the sprites dance. It's like, well, that, the relationship between environment, the language itself and the environment, and then the execution space. Short answer is like, not really, but super interesting. And I think that could be, so what I was trying to do is understand affordances of blocks-based environments to inform the design of hybrid or, text-based things. But you could say the same about understanding students' perceived affordances of text-based as a way to kind of go the other direction and inform block-based, which I think is a neat idea. So short answer is not yet, but great question, good suggestion.
Mm. good. And I was when we talked, I asked you how old the students were, because we often think about block-based programming as sort of primary school age, and these students were around 15. Was that, did we? Yeah, so they're sort of into high school before. And so I think there were lots of comments in the chat around, you're teaching Java. Do you want to comment on that? Because the difference from the block-based to the Java, I think looking at the comments, seemed quite a jump.
Yeah, yeah, thanks for bringing up that point. I should have been more explicit. First, it's important to say that my using Java for the second half of the class was not my endorsement of Java as the right language to be teaching. As I'm sure some of you know, in the United States, the kind of like the capstone high school computer science course is this advanced placement computer science A exam that is currently being taught in Java. And so like, so in other words, that's to say Java is kind of like the final language in the high school learning trajectory. And so the class that I was in was a class that historically had been used as like a lead into that final class. And so they're using Java was essentially because they were preparing them for this next class, and that next class was Java because it had to be Java. And like knowing full well that there's all sorts of kind of landmines in terms of learning Java and Java syntax and things like that. Yeah, and then another thing to mention in the text-based condition I used in the introductory environments, so the blocks hybrid text, the language that I used in that was called CoffeeScript, which is kind of like a Python-y version of JavaScript, where it's syntactically a lot lighter than JavaScript, so no curly braces or semicolons, and uses like white spaces, ways of defining nesting and things like that. And that was done in part to make the text-based a bit easier from the get-go for those students, as well as kind of ensuring that there was some, there was a hurdle to be crossed in moving from the introductory environment to Java. So it wasn't like they just had an extra 5 weeks of Java. It was trying to understand an extra 5 weeks in the text-based modality as opposed to a particular language. Yeah, so there's some thoughts on that. And again, like happy to chat more about that. But part of it is just like in working in public schools, you're kind of you kind of give up, you have to cede a bunch of control in terms of some things, in terms of like students and classes and programming languages used and stuff like that, just because you have to. Yeah, thanks for asking.
And Julie who doesn't work for Raspberry Pi, has just pointed out to all people on the call that do work for Raspberry Pi that there's a Raspberry Pi online course around going from Scratch to Python, which you can find on our FutureLearn, with our FutureLearn courses. Okay, any other questions? Oh, Tim's you've got your hand up. Tim.
It's more an observation, perhaps. In your research, you had a lot of people for whom English was not necessarily the first language, or they had another language back home. And most text languages are based in English. And so learning to program in text is another mental overload compared with the text.
I was going, I forgot.
But there again, your block language was also based on English. Now, I'm living in France, and so my problem would be introducing this to French. And Scratch is fully translated. You can load up a program which was written in English in a French environment, and all the blocks are translated in French. I can't do this in Python. And so the mental overload for people who don't have English as the first language, in Scratch at least, is a fantastic entrance. Whereas if you go into any professional text language, you're going to be confronted with, in addition, English language as the basis of it.
Yeah, great comment. And I mean, I think to your point about the internationalization efforts in Scratch, where you can program in kind of, I don't know how many languages they support, but it's just and Blockly as well is just a huge number. The ability to program in a native language is just a huge potential of affordance. And so falling into this, like, blocks are easier to read. I had described that as natural language, but we could also imagine that as easier to read because it's in the learner's native language. As just like a tremendous instructional advantage. In terms of English language learners in this study, and so I think the statistic was like roughly half spoke a language other than English at home. These were students in high school in a selective enrollment school, which means, which essentially means that they had historically succeeded academically in English instruction. So that makes me a little less concerned about the English language learning dimension to how students were doing, just because they had historically been successful relative to peers at their local schools, which isn't to say that it can be ignored in all situations. And I'm sure that like it played some role in this particular context. I just don't think it was a particularly big one given that like selective enrollment school characteristic of the student population. And I know that, again, like one of the things that I like to do when given the chance to give these talks is essentially advocate for more people doing research in computing education. And so before I was talking about, oh, it'd be great if more people are doing research on pedagogy and the relationship between pedagogy and environment. I think this point you bring up about in English language learners or like learners in a second language and kind of the relationship between native language and programming language and affordances of like programming in French and then translating programs written in French into English or always staying in French, or like, I think there's just a bunch of really interesting work to be done there. And I think computer science and programming in particular, like kind of lives in an interesting, exciting space that is not necessarily true of most other disciplines, like learning math in French or Spanish, like it feels like a different thing just because of the like relationship with natural language. Again, long-winded way of saying like, don't have a great answer, but would love to pursue it further. And particularly in the area I'm now doing research, there's a lot of native Spanish language speakers. And so there's been some exploration of teaching Scratch using Spanish keywords for English language learners, especially among like 3rd, 4th, 5th graders who are still working to kind of master English. But yeah, great comment. Appreciate the feedback.
Good. I was just going to say we've run out of, but Joe, we've run out of time for questions. Joey, do you want to ask your question quickly? Is the last question there?
Oh, sorry. Yes. It was just, some of the negative attitudes towards blocks by some students. I'm just curious, what has history told us about how we transitioned to text in the first place? Did people think that was inauthentic in the past? Do we need to come up with a kind of a block-based system that is kind of indispensable?
You can't ask that question when there's only like 1 minute left. It'll be the first question, so we can talk about it for 20 minutes. Yeah, great question. I don't know the answer. So one thought, and this is one thought, some work that I did that isn't a part of this, I did some work with an industrial robotics company that was trying to design a block, essentially trying to make it so that novices could program industrial robots, which historically take people with advanced degrees in robotics and robotics programming to control. And so we ended up making a block-based version of a language to control an industrial robot, and then ran some studies to show that sure enough, adults with very little, with no prior programming experience could write functioning kind of pick and place routines. I bring that up because to me, that feels like a way to push back against the authenticity thing isn't to make block-based languages more like professional languages, but instead to broaden the utility of block-based languages and bring block-based languages to a lot more context. So now it's like, if you're querying a database about whatever, like you can now do that in a block-based interface. And that is completely authentic because like you're writing the same queries and dealing with the same data. So it's just like a shifting perception of the utility of block-based environments, as opposed to kind of making block-based environments more like text-based. I don't know if that totally answers your question, but that's kind of how I think about it.
Yeah, no, I would agree. I think, it's there's a certain group of, let's call them programmers who, have a task to perform. How they do it is almost incidental. Yeah.
Oh, and I see there's some interesting comments from Neil and others about, yeah, these historical, right, assembly to text or, yeah, assembly to high level languages and things like that.
We've got a very active chat today. It's lots of comments going in there. So thank you. So thank you to everybody for your questions. We have now run out of time. Can we thank David again for, I'll just wave my hands in the air madly to thank David again for his talk all the way from USA to come and talk to us. It's lovely to have this online forum to do that. And
can I just say one quick thing? Everyone, please, all the papers that I shared, all that research has been published and freely available on my website. If you have any follow-up questions or anything like that, please do not hesitate to reach out. I have the lovely feature of having a relatively unique last name, so you can just kind of search for Weintrop and you'll find your way to me and my website. So please don't hesitate to reach out. Happy to keep the conversation going. And thank you for having me.
Oh, great. I have that advantage too with the name. Yes, so we'll be sharing David's presentation. We'll be sharing the video when it's ready. There's always a blog post to go after the presentation to follow on the conversation. That's great. And if you've spoken, you don't want your video to be shown, please let Diana know at research@raspberrypi.org. And just the last thing to do is to announce that our next seminar will be on January the 5th. We're welcoming Peter Kemp and Billy Wong. Peter's from King's College London and Billy Wong's from University of Reading, and they're speaking about computer education for underrepresented groups. And you might remember that this is the beginning of our new series that we're doing in the spring on diversity and inclusion. We've got three seminars on diversity and 3 on inclusion, and we're really looking forward to see you in the new year. So happy Christmas, everybody.